Well, I know most of you guys are here on this channel for the first time, and also probably you are wondering that what the heck is this RDH code? Well, this is our e-learning channel for the people who want to learn how to code. So you are going to see a lot of tutorials and courses from this channel in the future. Now let's just get on the topic. In this series, we will start from scratch and learn the various concepts in Svelte. In this introductory video, I'll briefly talk about what's and whys of Svelte and also what you need to have to get started with Svelte. Alright, let's begin with what is Svelte. Svelte is a component framework you can use to build high-performance web applications. What is component framework? Well, a component framework helps you write application code in a declarative manner. But what do we mean by declarative? If you worked with some of the programming languages like C or C++ for example, you are probably aware of the imperative programming model, where we usually list down the steps explicitly and ask the library to do one thing after the other. In the declarative version though, we are simply saying that what outcome we want. We just have to tell Svelte what we want the UI to look like and it will take care of the rest. It's a lot easier to read and write and there is no code duplication. So you now know what is Svelte. It is a component framework for building web applications and you can use it to progressively build an existing application or build an entire single page application from scratch. But the more interesting question is, why Svelte? Or how does Svelte is better than compared to other frameworks or libraries like React and Vue? The first thing is that unlike React or Vue, which do a bulk of their work in the browser, Svelte shifts that work into a compiled steps. That happens when you build your application, and because of this there is no need to bundle the framework code, and so the bundle size is smaller. Of course, this is something that happens behind the scenes, which you don't have to worry about when writing code. What you do have to worry about though is the developer experience. If you worked with React or Vue, you would find yourself with the problem of what to choose for state management. Redux or Vuex are not the most simplest libraries to understand. Svelte on the other hand provides Svelte stores out of the box, which is really easy to work with, and not just that, Svelte has a ton of features which makes your life easier by providing answers to your questions that you might have when building almost every application. Like, how do we add motion and element transitions? How do we handle user input via form elements? How do we add CSS to our components without polluting the global scope? How do we edit the head tag for our single page applications from within our component, and a lot more? Svelte has you covered. When starting out with web development, it is very comforting to have one recommended approach to do something and not to be worried about making a wrong decision. Okay, I can say that Svelte is going to be a great addition to your skill set. Now then, what are the prerequisites to get started with Svelte? Well, HTML, CSS and JavaScript fundamentals are absolutely necessary. For this course, I'll also making use of ES6 Plus features. So a knowledge of modern JavaScript is also essential. You don't have to be an expert in these prerequisites, but there are a few modern JavaScript features that make it so much easier to write Svelte code. My goal is to make sure we all advance from a complete beginner to be an expert in Svelte. What's going on guys? Today on RDH Code, we're gonna create our very first Svelte application. But before that, we have to set up our development environment so that we can write our very first line of code. So let's begin. For Svelte, you need two things to be installed in your PC. Node and a text editor of your choice. For Node, go to node.js.org and then here you're gonna see this type of stuff. What you need to do here is click on this green button guys. Now look, download the LTS version of the Node.js. This LTS stands for long-term support. Means it's a stable version of Node.js guys. And why is it green? Who knows, maybe because of this. Now download and install it. If you already have it installed, make sure that you have the latest updated version of Node.js. Now you can choose any text editor you like, but I personally use Visual Studio Code. You can download and install it from code.visualstudio.com. After installing the VS Code, go in the extension tab and install the Svelte for VS Code and Svelte 3 snippets extension. Together they provide syntax highlighting, code snippet, formatting support, auto-completion and a lot more features specifically for Svelte. Now before we begin with the code, there is one point I want to highlight. When it comes to the world of Svelte, there are two things you should know about: Svelte and SvelteKit. SvelteKit is an application framework powered by Svelte. If you are familiar with React and Vue, you might be aware of frameworks Next and Nuxt.js. Next.js is a framework powered by React and Nuxt.js is a framework powered by Vue. Similar to that, SvelteKit is a framework powered by Svelte. It adds features like routing and server-side rendering, which are great for building medium to large scale applications. What I always recommend is to learn React before Next, Vue before Nuxt, and of course Svelte before SvelteKit. So in this tutorial series, we're gonna learn Svelte first and then we'll head towards the Svelte kit. The reason I bring this up is because we can create a new Svelte app by following instructions on the Svelte side as well as on the Svelte kit side. As beginners though, we are going to follow the instructions of these two sides. Alright, now to get us started, I have created a folder called Svelte and opened VS Code inside that folder. This folder is going to be our workspace for the rest of our series. To create a brand new Svelte project, all we need is one line of code. In the terminal here, run the command npx dgit Svelte.js/template followed by the name of project. Let's just call it RDH code. The dgit command simply clone the Svelte template repo without the git history. The command takes the few seconds to run, and once the command completes, you will see a new folder called RDH code. This folder contains our Svelte application. To run this application, first navigate inside the folder. So cd RDH code. Then run the command yarn to install the dependencies. If you are using npm, you have to run npm install. Once the command completes, run the command yarn dev or npm run dev. The command will set up a development server on localhost port 8080. I can control click to this link and head towards the browser. Here you can see that our application is up and running. By default UI features, here is a heading that says hello world followed by the line of text that tells us to check the Svelte tutorial to learn how to build Svelte apps. But you guys don't have to click on this. Why? Because you have this. So stay tuned with this series and you will be pro in Svelte in no time. Okay, what's going on everyone? Welcome to the RDH code. So we finally finished setting up our development environment. Now it's also really important that you understand the files and folders present in the generated project and how to control the flows when you run the application. Let's take a look at that in this video. I have opened the RDH code project in VS Code, and you can see that at the root level we have 4 folders and 5 files to begin with. Let's start with the important bits in package.json. This file contains the dependencies and the scripts required for the project. You can see that we are using Svelte version 3 and that is listed as a dev dependency. Svelte is only used during the compilation phase and never bundled into the code that is sent to the browser. We then have rollup, which is a model bundler, and a whole load of roller plugins listed as dev dependencies. Rollup is responsible for transforming the Svelte code we write into JavaScript code that the browsers can understand. There is one dependency which is the server CLI. It allows us to run a static file server. We also have 3 scripts, dev for development, build to create a production ready version of the application, and start for serve CLI to serve the built application straightforward to package.json. As you can see, next we have the configuration file for rollup, rollup.config.js. This is the config file that is used when we run the command yarn dev or yarn build. If you are interested in the various configuration, I recommend you to take a look at rollup documentation. Next we have the yarn log file. Based on whether you prefer npm or yarn as a package manager, you are going to see yarn log or package log file. They simply ensure consistent installations of your dependencies and you don't have to really worry about them. We also have git ignore and readme file. Alright, next let's talk about the folders. The first one is node modules. This is the folder in which all the dependencies are installed. It is generated when you run the yarn command or npm install command. The next folder is the public folder. This folder contains static assets that are published when you want to go live with your application. It contains 3 files. We have a fab icon which you see in the browser tab and is nothing Svelte specific. We also have a global CSS file which includes styles that are applied to our entire application. And finally, we have an index.html file, which is the only HTML file you are going to have in your application. We are building single page application right now and this is it. The view might dynamically change in the browser, but it is this HTML file that gets served up. Typically, you are not going to add any code in this file. Maybe some changes in the head, but definitely not in the body tag. You want Svelte to control the UI, and for that purpose, we have CSS and JS file. So /build/bundle.css /build/bundle.js. These files are from the build folder, which get generated when you run or build your application. Now, please make a note of this empty body tag as we will come back to it shortly. The next folder is the scripts folder, which contains a file pertaining to TypeScript setup. Since we are going to learn Svelte with just JavaScript, we don't have to worry about this for now. The next folder is the source folder, which is the folder we will be working with the most during our development. The starting point for our Svelte application is main.js. In main.js, we import the root components, which is app component, and invoke it as a function specifying the document body as the target element. And if you can recollect, we have an empty body element in our index.html file. So everything inside this body tag will be managed by Svelte. For the application, the app component is rendered inside the body element. That brings us to the app component, which is present in app.svelte. Now the .svelte file extension, I bet, is something new to you if you are learning about Svelte for the first time. We will talk about these .svelte files in the next video, but for now let me tell you that it is a file where you specify the HTML, CSS and JavaScript corresponding to a portion of the UI you see in the browser. You can see here we have a script block with a variable called name. For the HTML, we have the main HTML tag with an h1 tag and a paragraph tag. This is the text we see in the browser below the HTML. We also have some styles specified within our style block. The app.svelte file pretty much represents the UI you see in the browser. So that is the folder structure of Svelte application created using the dgit command. Next, let's understand the control flow when you run this application in the terminal. When you run the command yarn dev, index.html file is served in the browser. Index.html contains a reference to bundle.js. The bundle.js is your main.js file compiled to a JavaScript format that the browser can understand. The Svelte code renders itself within the body tag. So if I inspect the heading element, you can see the main tag as a child of the body tag. This is nothing but our app component, and the name of course is a name from main.js, which gets replaced in the HTML because of the Svelte compiler. So hello name replaces name with world, which is the hello world, and that is what you see in the browser. We will of course learn more about this Svelte magic in the next videos. So this is pretty much all about the project structure for now. The control flow from package.json, dev script to index.html, bundle.js script to main.js, and finally app.svelte. Now I'm pretty sure this file extension, which is .svelte, is new to you. So let's discuss more about that in the next video. What's up everyone, today on RDH Code, we are going to learn about the .svelte file. In the previous video, I talked about the .svelte file in 1 or 2 sentences I guess. In this video, let's understand a bit more about this file type. A .svelte file is a custom file format where we write our code using a superset of HTML to describe a portion of the UI. For example, in our project we have one .svelte file, namely app.svelte, which is responsible for the heading and the paragraph in the UI. So a .svelte file is responsible for the portion of the UI. Next, let's understand the code that goes inside a .svelte file. Each .svelte file consists of 3 sections: script, markup, and style. The script section is where the data and the logic for the markup is maintained. So you could say it is like the JavaScript of your UI. The markup section is the HTML of your UI. It defines the structure. The last section, which is the style section, where you specify the styles related to the HTML written in your markup section. The script section goes within the script tag, the style section goes within the style tag, and everything else is part of the markup section. As you can see, HTML, CSS and JavaScript, that is all you need to define a fully functional and styled portion of the user interface. So in Svelte, instead of dividing the codebase into 3 huge layers which then come together to form the UI, it is instead divided into 1 or more Svelte files where each file is responsible for its own markup, styles and logic. And what you do have to keep in your mind though is that the browser does not understand what a .svelte file is. So Rollup with the Svelte plugin is going to parse this file, extract each of the 3 sections and assemble them back into a format that browsers can understand. Since we are using the Svelte template repo, all of this is already taken care for us. Alright, now that we have a bit more information about the Svelte file, let's discuss 2 more points which will set us up to finally get started with some code. The first point is about components. Right now we have a Svelte file called app.svelte. In Svelte, a .svelte file represents a component. A Svelte app can contain 1 or more of these components. When learning Svelte as a beginner though, there is a lot to learn with just one Svelte file. We don't have to worry about multiple Svelte files and the component architecture to begin with. So to keep this simple, you are first going to focus on all the concepts that can be learned using just one Svelte file. When we have a good understanding of how the script, markup and style section work together, we will then dive deep into the world of concepts in Svelte. I promise you we will come back to this topic of components later on in this series, when it will make much more sense than right now. All we need is just one app.svelte file to understand a whole bunch of concepts that Svelte has to offer. The second point is about what we are going to learn pretty much for in the upcoming videos. A minute ago I mentioned that a .svelte file contains markup as well as the script which contains the logic for that markup. Let me tell you that a major portion of working with a .svelte file is wiring up the data and logic to the markup. That is connecting the data present in the script section to the HTML present in the markup section. This is the declarative programming approach I was mentioning in the very first video. All you have to do is let Svelte know how you want to bind your data to the HTML and Svelte will take care of the rest. It is this part of letting Svelte know what exactly we want the UI to look like. So let's finally get started with some code in the next video.
What's up everyone, welcome to the RDH code. In the last video we talked about single file components, which is basically a Svelte file in our project. We have one Svelte file which is app.svelte. We learned that a Svelte file can contain three sections, namely the script section, the markup section and the style section. I also mentioned that the script section contains the data and the logic for the markup section, which ultimately is responsible for the UI. In this video, let's understand how to bind the data from the script section to the markup section more specifically. Let's start with binding text from the script to the markup. Now we want to start fresh, so in main.js remove the props object. That is to do with components, which we will take a look at further down in the series. In app.svelte, let's have an empty script section, and for the markup, let's have an empty main tag. We could remove this as well, but it center align the text, which I like to have for the videos in the series. The style section can remain untouched. Alright, now for some code in the markup. If we were to type hello Rahul and take a look at the browser, you can see the name being displayed. However, this is static text which can never change. Typically in web applications, though, the UI is data driven. Content you see in the browser can be dynamic and needs to change based on the application state. So we need to maintain the data in the script section and then bind the data to the HTML in the script section. So we can define a constant name and set it to Rahul. Now we have to bind this name to the HTML defined below. And to do that, we use a pair of curly braces. So within the main tag, instead of Rahul, specify curly braces, and within the curly braces we specify the constant name. If you now take a look at the browser, our output is still the same. Change name to Monkey D. Luffy and we see the text hello Monkey D. Luffy. So what happens here is that the name constant inside curly braces is replaced with its value. So name is replaced by the string Monkey D. Luffy. In fact, within curly braces you can specify any JavaScript expression you want to. I can change name to 5 plus 5 and we see hello 10 in the browser. The curly braces support any valid JavaScript expression. So this is the first fundamental concept in Svelte, binding text from the script section to the markup. In the next video, let's take a look at binding HTML.
What's up guys? In the previous video, we learned about the usage of curly braces to bind text to the UI. What you have to keep in mind about binding text is that strings are inserted as plain text, so HTML characters have no special meaning. Sometimes though, we might have to render real HTML in the browser. A possible use case is when a user is asked to fill a form where one of the fields is a rich text editor, the user would be allowed to bold or italicize the input. And if you want to display that input value, let's say in a read-only mode, you need to render the value as HTML with the bold tags, font colors and whatnot. In such scenario, we can use the @HTML prefix within curly braces. Let's take a look at an example. Let's say we have a data property whose value is a string enclosed with both tags. Let's add a new constant, so const channel, and this is going to be equal to RDH code. But within a pair of bold tags, if we try to bind this data to our markup with curly braces, you can see that the value gets rendered as a plain text. The bold tags is also rendered in the UI. To render proper HTML, we add the @HTML prefix. So within the curly braces, add HTML as a prefix before channel. Now if you save the file and take a look at the browser, we have the channel name rendered in bold. Like I mentioned, you would at least once in a complex project come across the need to render HTML in the browser, and this is the way to go about it. Well, there is a word of warning though. When you use the @HTML prefix, it is very important to keep in mind that you should only render the content that you trust. If you are using a third-party API, it is very risky to use the @HTML prefix because it might lead to cross-site scripting attacks and making your application vulnerable to security threats. Let me show a very simple scenario which could cause anxiety for your users. I'm going to copy paste a new constant within the script section. So const hack, which is simply an anchor tag, on click of which you alert the text, you have been hacked. The anchor text itself is win a prize. So now bind this to the markup using the HTML prefix. So add HTML hack, save the file, head to the browser. You can see that when I click this win a prize link, I get an alert you have been hacked. Of course, we as a developers know this is a simple alert. But for user browsing your site, this is definitely not favorable. Also, hackers are capable of injecting much worse threats into your site than a simple alert dialog. So use the @HTML prefix to render real HTML, but be very cautious of what you are rendering. Thank you guys for watching. Make sure to subscribe to the channel and I'll see you guys in the next video. What's up guys, welcome to the RDH code. In this video, let's take a look at dynamic attributes in Svelte. It is possible to bind data to HTML attributes such as ID, class, style, and even Boolean attributes such as disabled for an input element. The same curly braces we have learnt about can be used for attribute binding as well. Let's take a look at an example. I am going to add a constant, so const heading ID is equal to heading. Now we can bind this to an HTML element ID property. So as to tag, this is our heading and ID is going to be equal to curly braces, and we specify heading ID. Let's save this and head towards the browser. You can see the heading element is being displayed. If you inspect the element, you can see that the ID is in fact heading. If you are rendering a list of elements and you want each element to have a unique ID, dynamic attribute binding will help you. And what is cool about attribute binding is that you can use a shorthand if the attribute name and value are the same. So if we were to have a constant called just ID, instead of having ID is equal to ID, we can specify a shorthand of just the curly braces with ID inside. Svelte will infer that you are trying to bind to the ID attribute. Take a look at the browser. You can see that the ID attribute is still present with the value of heading. Now attribute binding can also be used to bind Boolean attributes. The behavior though is slightly different. I'm going to define another constant. So const disabled is equal to true. Now we can create a button and set the disabled attribute equal to the disabled constant. So button, the text is bind, and we can set disabled is equal to disabled, or use the shorthand and specify disabled within the curly braces. Save the file and head towards the browser. If you inspect the element, the disabled attribute is present. If I now change the disabled value to false, the button is no longer disabled. But if you inspect the element, you can see that there is no disabled attribute. So in the case of Boolean attributes where their mere existence applies true, as in the case of disabled attribute we have just seen, the HTML attribute will not even be included in the rendered button element if the disabled property is false. So these are the two examples of attribute binding. When building applications, a more common need for attribute binding is binding to the class attribute on an element. It's pretty similar to what we have just seen, but there is an additional detail to class binding. Let's take a look at that in next video. So today on RDH code, we're going to learn about class attributes. In the previous video, we learned about attribute binding. In this video, let's continue with attribute binding but focus on one specific attribute, which is the class attribute. Let's start off with the class attribute in its most basic form. In the style section, I'm going to define a new class. The class name is underline, and we simply set text decoration to underline. I'm going to add an s2 tag with the text as underlined text to apply the underlying class we have just defined. We specify the class attribute and then assign the class name. If we take a look at the browser, the class and its styling is applied on the HTML element. Now this is an example of static class. Static classes are the ones that never change and will always be present on the HTML element. But in a web application, you might want to manipulate an elements list of classes, in other words. You need dynamic classes, which allows you to add or remove classes when things change in your application. Dynamic classes are similar to static classes, but we have to use curly braces in order to bind a JavaScript expression to our class attribute. Let's understand with an example. I'm going to begin by adding two new classes, Danger, where the color is red, and Success, where the color is olive. In the script section, let me define a new constant called status and set it to Danger. Now in the markup section, we can bind this status value to the class attribute using curly braces. So s2 tag, the text is status and class is equal to within curly braces status. If we now go back to the browser, we can see the status text with red color. If I inspect the element, you can see Danger is applied as a class, which is the value of the status property. Change it to Success and the Success class is applied. This sort of class binding allows you to change the class dynamically based on some data. For example, if there are errors in a form field, you might want to apply the Danger class. If there is valid data in the form, you might want to apply the Success class. So this is pretty much the basic of binding classes in Svelte. However, there is more to it. Since the class attribute accepts any JavaScript expression, we can do pretty cool things like conditional binding. So in the style section, I'm going to take the context of displaying movies names. If the movie is promoted movie, we want the font style to be italicized. We can now add a new constant called isPromoted that serves as the condition for the promoted class to be applied. Now in the markup, we can use the ternary operator to conditionally apply the promoted class only if isPromoted is true. So as to tag again, the text is going to be the movie title and then class binding. And within the curly braces, we are going to specify if isPromoted is true, apply the promoted class. If not, don't apply it. If you take a look at the browser, you can see that the text movie title is italicized and the promoted class is applied on the s2 element. If I change isPromoted to false, the class and styling is removed from the element. This pattern of conditionally applying classes is so common, Svelte provides a special directive that allows you to toggle classes based on some conditions. Now a directive is like a custom attribute that controls the element's behavior in some way. In our case, it controls the toggling of classes on an element. So instead of class isPromoted, we can have the directive class colon and the class name. We want to apply which is promoted, and this should be applied based on the value of isPromoted. So what happens is that the JavaScript expression isPromoted is evaluated first. If it is true, promoted is applied as a class on the element, else it is not. If I set isPromoted to true again and go back to the browser, you can see the promoted class being applied and the text is italicized. Of course, this class directive also has a shorthand syntax. If the directive class name and its value match, we can concise this line of code. So if a constant is just promoted, instead of isPromoted, we can completely remove the equal signs and the right hand side. So class colon promoted, head back to the browser and our class binding works as expected. So this is pretty much is about binding class and conditionally binding classes in Svelte. Thank you guys for watching. Make sure to subscribe to the channel and I'll see you guys in the next video. What's going on everyone? Now today on RDH Code, we're gonna learn about conditional rendering. When you are building Svelte applications, you may often need to show or hide some HTML based on certain conditions in Svelte. Well, Svelte makes it really simple to do that by providing 3 special HTML blocks. They are if block, else block and the else if block. The 3 blocks work similar to any other programming language where we use if else and else if statements. The only difference here is that we render HTML elements rather than execute some logic. Let's understand how they work with an example. Let's consider a very simple scenario given a variable we need to display. If it is 0, a positive number, a negative number, or not a number. Let's begin by defining a new constant. So const num is equal to 0. First, let's check if the number is 0 or not. We begin by adding an if block. A syntax is curly braces, then the hash symbol, followed by if keyword. This is followed by the expression we want to evaluate. Our expression is num is equal to 0. If it evaluates to true, we need to output some text. So let's add an s2 tag with the text the number is 0. The hash if within curly braces represents the opening of the if block. We close this if block by adding another pair of curly braces, but this time a forward slash followed by the if keyword. If we now save the file and take a look at the browser, we should see the text the number is 0. If I change the number to 5, the expression evaluates to false and the heading is not rendered in the browser. Fairly simple as you can see. But let's now improve this. Instead of not displaying anything, let's display that the number is not 0. And for that we make a use of the else block right after the s2 tag. We are going to add another block represented by curly braces. But this block is not the start or the end. It is a continuation block and is represented by a colon. This is followed by the else keyword. Within the else block we add another heading that says the number is not 0. So as to tag, the number is not 0. If we save the file and take a look at the browser, the text now reads the number is not 0. We are conditionally rendering our HTML based on data defined in the script section. If the number is 0, we display the first heading, else we display the second heading. Now when you just have an either or condition, the if-else blocks are sufficient. But if you have more number of conditions, then you have to make use of the else if block as well. Let's add a few more conditional HTML elements. Let's display if the number is 0 or negative or positive or not a number. Now we are already checking if the number is 0. Next, let's check if the number is negative or positive. So right after the first s2 element, we add the else if block. The syntax is curly braces, colon, else, space, if, and this is followed by the condition. The condition is that num is less than 0. Now if this condition is true, we render another heading that says the number is negative. Make a copy of these 2 lines, paste it, change condition is num greater than 0 and the text negative to positive. So if the number is greater than 0, we output the text the number is positive. Finally, if none of the conditions are satisfied, we display that it is not a number. Let's save the file and verify if this code works. Right now, num is set to 5 and hence we see that it's positive. Let me change it to -5 and you can see that the number is now negative. If I assign a string, you can see that it is not a number. Our conditional rendering markup is working as expected. Alright, that is about the if-else and else-if logical blocks in Svelte. They are used to conditionally render HTML elements in the UI. Thank you guys for watching. Make sure to subscribe to the channel and I'll see you guys in the next video. What's up guys, now in this video we'll see how list rendering works. So when you build web applications, a common scenario is to display a list of items. For example, a list of names, a list of products, a list of courses, so on and so forth. So what we want is to repeat some HTML for each item in the list in Svelte. We can achieve that using the each block. Let's understand the syntax with an example. In the script section, I'm going to define a constant called names, which is an array of 3 strings, Bruce, Clark, and Diana. Our aim is to display this list of names in the UI, for which we need to use the each block. If you can recollect from the previous video, you know that we use curly braces to represent the block in the markup. So within the main tag, I'm going to add a pair of curly braces. We represent the starting of a block with the hash symbol, and this block is the each block. We end this block with curly braces, a / and the name of the block again. Now we need a way to get hold of each name in the names array. And the syntax for that is names as name, and this is Svelte specific syntax. So let's understand what is happening here. In each block, names is the data defined in the script section, and name is simply analyzed to refer to the current item in the loop. Since we have the each block basically iterates 3 times with names referring to each of the names. This name is what we bind to the HTML using curly braces. So within the each block, add an h2 tag. We are going to bind the text name. So first iteration name is equal to the string Bruce. Second iteration name is equal to Clark. And third iteration name is equal to Diana. If we save the file and take a look at the browser, we see the name being displayed. If you inspect element, you can see that the h2 tag is repeated 3 times and the inner text is Bruce, Clark, and Diana. So the h2 element has repeated itself for each name in the names array. Sometimes you might also want to get hold of the index when rendering a list. For that, Svelte provides the index in the each block, which you can use if required. So instead of just name, we get hold of name, index. Then while binding, we can also bind the index. Index plus 1. If we take a look at the browser, we can see 1, 2, 3 to the names. Index starts at 0 and hence index plus 1 will represent 1, 2 and 3. Now a small variation of this is iterating over an array of the objects. Let's quickly take a look at an example. I'm going to create a new constant called full names, and this is going to be equal to an array of objects. So we have first name and last name, Bruce Wayne, Clark Kent, and Princess Diana. Now the aim is to display the list of full names in the UI. If you have understood the first example, this should be fairly straightforward to understand. Within the main tag at the top, I'm going to add another each block. So hashtag or hash symbol followed by the keyword each. We also need to close the each block using the /. Now for the iteration, we are iterating over full names and we are going to alias each object as names. We can also get hold of index within the each block. I'm going to add an h2 tag and we can render index plus 1. But this time while rendering the first and last names, we need to access name.first and name.last. Name here refers to each object in the iteration. If we now save the file and head to the browser, we should be able to see Bruce Wayne, Clark Kent, and Princess Diana. And of course the number are also displayed. Alright, you should now have a good understanding of the each block and its usage to render a list of elements in Svelte. But there is still a missing piece, which is the key expression that can be provided for an each block. Let's understand more about keys and lists in the next video.
What's going on everyone, welcome to RDH Code. So in this video, let's understand about the key expression when rendering a list of elements. In Svelte, it's a common practice and also recommended to provide a key expression for the each block whenever possible. To specify the key expression in the each block, opening within parentheses, we specify a unique value. For our second each block, this could be the name itself. Since it's unique within the name array, for our first each block, we could specify the name object itself. But strings or numbers are recommended, since they allow the identity to persist even when objects themselves change. So we can specify name.first.
If we now save the file and go back to the browser, there is absolutely no change to the list of elements being displayed. However, the key expression is used by Svelte to diff the list when there are data changes, or in simple words, the key expression helps Svelte identify which items in a list have changed, are added, or removed, and it plays a crucial role in handling UI updates correctly and efficiently. What I want to do is show you an example where the absence of the key expression can actually lead to bugs in the UI. I'm going to use Code Sandbox for this purpose. Now this example uses concepts in Svelte that we haven't covered yet. So let's focus on just the each block and the UI on right hand side. I will leave a link to this demo in the description for you to have a look at when watching the video. In the script section we have a constant called names with 4 strings: One Piece, Demon Slayer, Attack on Titan, and Tokyo Revengers. So who doesn't know what's this? For them, these are the names of anime shows. By the way, I don't think you guys don't know about what anime is. I mean, come on, everybody knows about One Piece, eh? So in the template, we have the each block iterating over the list of names. In each iteration, we display the name, and we also have an input element to accept the last name as the anime ratings out of 10. As you can see this in the UI on the right hand side. Now along with this list, we also have a button called Shuffle, which simply shuffles the list of names in the array. So if I click on this button, you can see that the list in the UI is shuffled every time. Now let's enter some text in the input boxes. I'm going to refresh and then I'm going to rate these animes. And in advance, these are some random ratings, okay? So don't get offended. Well, that's another thing that One Piece is the best. So I'm gonna rate Tokyo Revengers 8, One Piece 10 of course, Demon Slayer 8, and Attack on Titan 9. Now I want you to closely observe what happens when I click on the shuffle button. You can see that names are shuffled, but the ratings don't shuffle. So we now have Demon Slayer 10 and One Piece 8, which obviously isn't what we expect, okay? Because it's not right. I click on shuffle again and the same things happens. This is the drawback of not using the key expression when rendering a list of elements. When you don't specify the unique key, Svelte simply patches the value. This behavior causes the bug when working with temporary state like the DOM state or when adding or removing elements to the list. If we now add the key expression name, refresh, enter the ratings, One Piece 10, Demon Slayer 8, Attack on Titan 9, and Tokyo Revengers 8. And now click on shuffle, we can see that the behavior is as expected. The anime shows shuffle, but this time ratings of each anime stuck with them. So the key expression is pretty important when rendering a list of elements. A typical value to provide the key expression is the ID property in an object, but any unique value will serve the same purpose. I wanted to ensure you understand why we use that expression, and hopefully this video did that. Alright, thank you guys for watching. Make sure to subscribe to the channel and I'll see you guys in the next video. What is up everyone? So today on RDH Code, we're gonna learn about event handling in Svelte. You most likely wanted to respond to events. For example, if a user clicks a button and submits a form or even just moves their mouse, you want your application to handle the events and execute some code. In this video, let's see how to handle events with Svelte. Our example is going to be that of a simple click counter. You can click on a button and the count value increments. I'm going to begin by defining a new variable. Let count is equal to 0. Make sure to use let and not const, as we are going to change the count value in the markup section. Let's add a button. So button, the inner text is going to have a binding to the count variable. So count, and within curly braces the variable count. And now our next step is to listen to the click event on this button. Now to listen to event in Svelte, we use the on directive. The syntax is on : followed by the event name. For our example, it is click. To this we assign a handler. So on the right hand side, begin with a pair of curly braces, and within curly braces, the handler is an arrow function where we are going to increment the value of count by 1. So on the right hand side, within parentheses, count is equal to count plus 1. If we now save the file and take a look at the browser, we have the count as 0. When I click on the button, count value increments by 1 and the updated value is rendered in the UI. And what we have seen here is an example of inline event handlers. The code to execute is present in the same line as the on directive. This is great for simple logic, but more often than not, the logic for many event handlers will be complex. So keeping your JavaScript code in the markup section is not the best idea. In such cases, you can define a function in the script section and assign that function as the event handler. Let's understand with an example. In the script section, I'm going to define a function called handle click. So function handle click, where we increment the value of count y 1, so count plus equal 1. In the markup, I'm going to make a copy of the button, but this time instead of using the inline event handler, we are going to assign handle click. If we now save the file and take a look at the browser, click on the second button and the counter still works as expected. Alright, this is pretty much the basics of event handling in Svelte. Use the on directive followed by the event name followed by the JavaScript code to execute, which can be an inline function or a function that contains more complex logic. Now there are a few more points to discuss about event handling. Let's quickly look at those. Sometimes you might want to access the event object, which gives more information about the event itself. Luckily for us, Svelte automatically passes the event object as an argument to the event handler. So in the handle click function, we can specify a parameter called event and let's simply log it to the console. If I now go back to the browser, open the console tab, click on the second button, you can see that the event object is logged to the console. This gives us a lot of information about the event itself. It's a mouse event, gives us the coordinates of the click event on the screen, tells us that the target is a button and the types of mouse event is a click event. This event object is exactly what you would find with pure JavaScript and is nothing specific to Svelte, but definitely comes in handy when dealing with the form inputs. What we do have to note here though is that the event object is automatically passed in only if you don't specify any arguments. If you do have to specify an argument, the syntax is slightly different. Let me show that to you. For our counter, instead of incrementing it by 1, let's say it accepts an increment size as its argument. For that, we begin by changing the handler into an arrow function. This arrow function automatically receives the event object as its argument. We simply pass that on as an argument to handle click, but after the first argument, we can specify our own argument. Let's specify 5. Make a copy of this button and specify 10. Now for the handle click function, I'm going to add a second parameter called step size and use that instead of 1. If you now go back to the browser, click on the first button, increments the count by 1. Click on the second button, increments it by 5. Click on the third button, increments it by 10. So if you ever need to pass arguments to your event handlers, this is the way to go about it. Alright, that is pretty much about the event handling in Svelte. Thank you guys for watching. Make sure to subscribe to the channel and I'll see you guys in the next video. Welcome about the fundamentals of working with forms in Svelte. If you are a front-end developer, you probably know that a considerable amount of work has to do with building forms. So it's really important that we understand how to capture user inputs using various types of form controls. Well, we have inputs, text areas, single select controls, multi-select controls, single checkbox, group of checkboxes, and of course radio buttons. Once we capture the values from the user, we also have to learn how to submit those form values. We are not talking about submitting to an API, but having a submit button that can at least log the form data to the console is definitely required. As you can see, we have a lot to learn about form handling, which is why I have split this topic into 2 videos. In this video, we will understand how to work with inputs text areas, single select drop-down controls, and multi-select controls. In the next video, we will learn about a single checkbox, group of checkboxes, radio buttons, and also how to submit the form on a click of a button. Let's begin for our example. Let's consider a job application form where the user is required to fill in the details. To ensure our form doesn't look too bad, I'm going to add some CSS. So within the style block for our label, after an input element, set display inline flags. I'm also going to comment out the center text alignment style. Alright, now let's get started with our form. In the markup section, I'm going to add a form tag, and within the form tag, I'm going to add a div tag. For our first form control, and this form control is to gather the name of the user. So label text is going to be name, and the for attribute is also going to be name. In the next line, let's add an input. Input type equals text and ID equals name, which corresponds to the for attribute on the label element. If we now save the file and take a look at the browser, we have our name form control. We can type in Rahul and input reflects that. However, the data is currently in the HTML section. We need to send it into the script section, and for that purpose, Svelte provides the bind directive. Now how does it work? Well, we begin by defining a variable that is going to keep track of the form control.
So in the script section, I'm going to add new variable, let's call it form values, and this is going to be equal to an object. This property in turn will contain another property called name, which will track the input control value that we have just created. So name, and the initial value of name would be an empty string. Now you could omit the form values property, but it makes this demo much easier, as you are going to see in few minutes. Now once we have created the name variable, we need to bind it to the form control. We do that using the bind directive. So on the input element, we bind to the value property, and this is going to be equal to form values.name. Now if you were to enter the name, it would be tracked in the form values object. Let's stringify that object in the markup section to visualize how the data binding works. So above the form tag, I'm going to add a div tag. Within the div tag, I'm going to add a pre tag. And then within curly braces, json.stringify form values and pass in null comma 2 to display in separate lines. If you now save the file and head to the browser, you can see that we have the form values object and the name form control in the form values object. We have the name property whose value is an empty string. If I type Rahul, you can see the same in our stringified representation. So we have the binding form, the HTML to the script data and back to the HTML. What is great about Svelte is that it understands the different types of form controls and bind values accordingly at the moment. You can see that if I type number, the value is still a string with double quotes. If I add type is equal to number, though the value is automatically converted into a number. You might think this is how it would normally work, but that's not the case in vanilla JavaScript. If you were to have type is equal to number, the value would still be a string. Svelte on the other hand takes care of the type conversion for us. So this is pretty much how the bind directive works. Let's now look at few more examples. Since the name controls was the first usage of the bind directive, I wanted to take some time explaining how it works. Now that you have a good idea, I'm going to go over the rest of the example fairly quicker. Alright, the second form control in our job applicant form is to collect the profile summary of the candidate. This requires 3 simple steps. Step 1. Add a new property. So within form values profile summary and set it to an empty string. Step 2. Add the HTML. So div tag, within the div tag, the label text is going to be profile summary, and in the text line we are going to add a text area field. So text area ID is going to be equal to profile, which should match the for attribute on the label, and this can be a self-closing tag. Now for the step 3, we bind the profile summary property using the bind directive. So bind colon value is going to be equal to form values.profile summary. If we now save the file and take a look at the browser, we have our text area field type in our profile summary, and the same can be seen in the form values object. I'm guessing you are now getting a hang of working with forms in Svelte. Let's take a look at the select dropdown next. Let's say that we need to ask the user from which country they are from. Again, this involves 3 simple steps. Step 1. Create a new property. Create a new property called country and set it to an empty string. Step 2. Add the HTML. Label for is equal to country. The text is going to be country. Now to keep this simple, we are going to add only 3 countries, and I am going to copy paste the options. So the first option is select a country which has an empty value, and then we have 3 countries: Spain, Canada, United States, and the corresponding values. Now for step 3, we bind the property using the bind directive. So on the select element, bind to value form values dot country. If we now save the file and take a look at the browser, we have our select dropdown. Select a country and its value is reflected in the form values object: United States, Canada, and Spain. Now it's also possible to have a multi-select dropdown. Let's say we need the job applicant to select a list of countries where they are willing to relocate. This again can be done in 3 simple steps. Step 1. Add a new property. Job location and the initial value is going to be an empty array. Remember, multiple values can be selected, so the initial value is an empty array and not an empty string. Step 2. We add the HTML. Now this is the same HTML for selecting a country with some modifications. So let's make a copy of the code and make the necessary changes. Copy the div block, paste it. The first change is the text. Change it to job location. The second change is the for and id attributes. Change it to job-location. So this is step 2. For step 3, bind the correct property to the bind directive. It is form values.jobLocation. The third and final change, add the multiple attribute on the select HTML element. If you now save the file and head back to the browser, you can see that we have a multi-select HTML element. I can select spin and the form values object updates with the value. Hold Ctrl and click on United States. That gets added to the form values object as well. Our multi-select elements works as expected. So let's take a look at the second half of the topic in the next video. In the last video, we learned about the bind directive and its usage with input text areas, single select dropdowns, and multi-select dropdowns. In this video, let's learn about its usage with a single checkbox, a checkbox group, a radio group, and let's also learn how to submit the form data. Alright, let's start with a single checkbox. Form control in our job applicant form, we want the user to let us know if they are okay with working remotely or not. Like in the case of other form controls, this also can be implemented in 3 simple steps. Step 1. Add a new property, remote work, and this is going to be initially false. A single checkbox typically indicates true or false, which is why we initialize the property with false. The checkbox by default is unchecked. Step 2. We are going to add the HTML. So div tag input type is equal to checkbox, id is equal to remote work, and after the input we are going to add a label for is going to be remote work, and the text is going to be open to remote work with a question mark. So that is step 2. Step 3, find the property using the bind directive. Now for a checkbox, we bind to the checked property instead of the value property. And this is very important to make note of. So bind checked is going to be equal to form values dot remote work. Let's now save the file. Make sure the styles from before is not commented out. And now head back to the browser. We should be able to see our checkbox in our form values object. You can see that the value is false. If I check the checkbox, the value is now true. So based on the state of the checkbox, the value of the property will either be false or true. Now that we understand how a single checkbox works, let's understand how to work with multiple checkboxes, or a checkbox group if you can call it that. In the job applicant form, we want the user to select a list of skills they are comfortable with. Let's add HTML, CSS, and JavaScript as 3 checkboxes, and the user can select more than one skill. Again, 3 simple steps. 1. Add a new property skill set. And this is an array as well, since the user can select multiple values. Step 2. Add the HTML. Now to save us some time, I'm going to copy paste the HTML and walk you through the code. We have the label for the checkbox group, which is skill set. Then we have 3 checkboxes. The first one is HTML, the label is HTML, and the value for the checkbox is also HTML. We have the for attribute on the label, which corresponds to the id attribute on the checkbox, and of course the input type is checkbox. Similarly, we have the second checkbox for the CSS and the third checkbox for JavaScript. Now step 3, bind the property to each one of the 3 checkboxes. But this time, instead of binding to the checked property, we bind to the group property. So bind group, and this is going to be equal to form values.skillset. I'm going to copy paste this on the other 2 inputs as well. If we now format the file, save it, and take a look at the browser, you can see 3 checkboxes for the skill set. Input in the form values of check, the property is an empty array. If I select HTML, the same is pushed onto the array. Select all 3, all of them get pushed on the skill set array. Our checkbox group works as expected. Alright, let's take a look at the final form control, which is the radio group. Let's say we need the job applicant to select their years of experience. It could be either to 0 to 2 years, 3 to 5 years, 6 to 10 years, or 10 plus years. The user can select only one option, which is why video group is the best form control for this purpose. Let's see how to implement it. Again, in 3 simple steps. First step, create a new property years of experience. This is going to be an empty string. Step 2, add the HTML. Now the HTML is very similar to the checkbox group. So I'm going to copy paste the HTML and walk you through the code. We have a label for the form control, which is years of experience, and then we have 4 radio buttons. Each of them have a label and an input of type radio. We also have the ID attribute equals to the for attribute on the label. The value attribute on the input is also set, and you can see I have also included the bind column group directive, which is our step 3. The binding is with the new property years of experience. If you now save the file and take a look at the browser, we should have the 4 radio buttons, and the initial value in form values object is an empty string. And when I select the radio button, its corresponding value is reflected. Our radio group control works as expected. Alright, now that we have a good understanding of how to work with various form controls, now let's understand how to submit this form data. We begin by adding a submit button to our form. So after the radio group control, a tag button and the text is submit. Now it so happens that when the submit button is clicked, the form emits a submit event which we can list to using event binding. So on the form tag we bind to the submit event, so on colon submit, and let's assign an event handler called submit form. This submit form is going to be a function which we can define in the script section. So function submit form, and the function receives the event argument. By default, a form submission will cause the page to refresh. To prevent that, we call event.preventDefault. And in the next line, we simply log to the console the form values object. Ideally, you would want to send this object to an API endpoint as the request body. But for now, I just want you to get an understanding of how to get hold of the form data when the submit button is clicked. Let's save the file, head to the browser and open the console. I have also quickly changed name to be of type text rather than number. I'm going to fill in all the form values and click on submit. If you take a look at the console, you can see that the object is logged with all the values that we have filled in. One last thing I would like to mention here is about event modifiers. Instead of writing event.preventDefault, we can add a modifier to the submit event. So let me remove the event object and the corresponding statement. On the submit event, we can specify a modifier using the pipe character followed by the modifier name. That is going to be preventDefault. If we now go back to the browser and submit the form, the page still doesn't refresh, similar to preventDefault. There are a few other modifiers which I'll leave for you guys to explore. Alright then, that is pretty much the fundamentals of form handling in Svelte. Thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video.
Welcome back everyone. Our next topic is the topic of reactivity in Svelte. There are 2 concepts to cover: reactive declarations and reactive statements. Let's go over declarations in this video and statements in the next. In the script section, I'm going to declare 2 variables. The first name is equal to Barney and the last name is equal to Stinson. In the markup, we can bind first name and last name. So as to tag, curly braces, first name space, curly braces, and the last name. Now take a look at the browser and we see Barney Stinson now. It's also possible to achieve these exact same results using reactive declarations. There is a special syntax to this, which is $sign followed by a colon. So instead of let or const, we use this followed by the variable name. Let's call it full name. This is going to be equal to first name followed by last name. Now in the markup, we can bind full name using curly braces. If we take a look at the browser, you can see the same output. So what we have done is composed a new variable from existing variable values. Full name is a property composed from first name and last name. In the browser though, both represent the same UI. Which brings us to the question, why would we use reactive declarations with this syntax when we can just bind variables? Well, there are a few things to go over. For starters, full name is more descriptive of the data it represents rather than a combination of first name and last name in the markup. Also, if a value like full name needs to be rendered in multiple places, reactive declarations make much more sense. A JavaScript expression that is repeated in multiple places only makes it harder to maintain the code. Let's look at another example to justify this point. I'm going to copy paste a new variable. The property is called items and is an array of objects. Each object contains an ID, a title, and a price. We have Xiaomi Note 10 for 200, a OnePlus Note 2 for 500 and an iPhone 13 for 1000. Assume these are the items in your cart on an e-commerce site. If we have to display the total cost of all these items, we could do that in the markup. So as to tag, total is going to be items.reduce. This accepts a function which receives the total and the current items. And we are simply going to return total is equal to total plus current item dot price, and the initial total is 0. And this is of course its total. If we now save the file and take a look at the browser, we should see the total as 1700. Suppose you have to display this total on the cart icon as well as the order summary. You could duplicate this expression, but as you might have guessed, it would mean that you have to maintain the same code in multiple places. Suppose you have to add a discount on the order total, you would have to tweak your code in more than one place. Curly braces in the markup should be used to bind simple data and not perform complex logic. The right approach is to use a reactive declaration. So in the script section, define another reactive variable called total. So $total and assign the expression we have in the markup. Let's move this line after the items array. In the markup, render total. If we now save the file and take a look at the browser, the output remains the same, and the good thing about reactive declarations is that they are automatically recalculated if their dependencies change. Let me explain with an example. In the markup, let me add a button to change the first name and last name values. So button, the text is going to be changed name, and on click of this button we are going to assign first name with Akagami and last name is going to be equal to Shanks. If we now go back to the browser, you can see the full name updates since first name and last name updated. You don't have to worry about updating the full name variable separately. Svelte handles it for you. But what you have to know though is that the reactive system works based on assignments. So when working with areas or objects, direct mutation will not cause a re-render. Let me show that to you with the items array we currently have. In the markup, let's add another button to add an object into the items array. So button, the text is going to be add item, and on click of this button, we are going to have items.push and we are going to push an item with ID 4. Title keyboard and the price is going to be 50. I think $50 is enough. If we now go back to the browser, we have the total as 1700 and the button to add an item. If we click on the button though, the value does not update. This is because there is no assignment. To fix this, we need to assign a new value to the items array. So I'm going to wrap this with parentheses and we are going to have items is equal to spread the current items and then add the new item. Now go back to the browser and click on add item and the total increments to 1750. Since the items array changed on the button click, the total is recomputed and the value 1750 is rendered in the browser. Again, you don't have to worry about letting Svelte know that it has to recalculate the total. Svelte will take care of it for you. So that is about reactive declarations. In the next video, let's take a look at reactive statements. Okay guys, see you in the next video. In the previous video, we learned about reactive declarations. We used the $colon syntax followed by a variable name to which we assign a value computed from other variables, for example, full name, from first name and last name. In this video, let's take a look at reactive statements. In Svelte, the reactivity system is not limited to just declarations. We can also run statements reactively. The $colon syntax remains the same, but what follows after is different. Let's take a look at an example. In the script section, we are going to use $colon and this is going to be followed by a console.log statement. So console.log, full name is first name followed by last name. So this statement is dependent on first name and last name, which means it reacts to changes in those values. If we head back to the browser, we see the initial log statement that gets executed. Full name is Barney Stinson. But if I now click on change name, first name and last name are updated and the log statement is executed again since the dependent values have changed. So full name is now Akagami Shanks. Now of course with reactive statements you can also have multiple statements by simply wrapping them within curly braces. For example, I can split this log statement into agreed constant assignment and then log the value of greet to the console. So open curly braces, close curly braces, and here we can have multiple statements. Const greet is going to be equal to this string, then we console log the greet constant. The behavior remains the same, and you are not limited to executing simple statements like these. You can even have conditions in your statements. Let's say we are implementing a value control display for our application. The user can set a volume between 0 to 20. So in the script section, I'm going to add that volume is equal to 0. And in the markup, let's display the current volume and also add 2 buttons to increment and decrement the volume. So button increase volume, and on the click of the button, volume plus is equal to 2. So the step size is 2. I'm going to make the copy of this change, plus to minus and increase to decrease. Now this will work fine, but the volume can go below 0 or beyond 20. To handle that scenario, we can use a reactive statement. In the script section, $, and then we are going to add our condition. If volume is less than 0, alert can't go lower, and we reset volume is equal to 0. Else, if volume is greater than 20, we are going to alert can't go higher. Volume is going to be equal to 20. So if we now save the file and go back to the browser, we can see that the current volume is 0. If I try to decrease the volume, we get the alert can't go lower. And if we try to increase it beyond 20, we get an alert can't go higher. A reactive statement with conditions works as expected. But what is great about this approach is that it lets you define the event handler logic in isolation to the side effect that needs to be run. In our example, on click, we just have to worry about incrementing or decrementing the count value. For the business logic of what should happen when volume reaches a particular value is separated from the event handler logic, which leads to cleaner and more understandable code. As you can see, reactivity is pretty powerful in Svelte, so do make use of it when required. Alright, with that we have pretty much covered all the fundamentals concepts in Svelte. Now it's finally time to start learning about component architecture and all details that revolve around it. Let's start learning about components from the next video. Thank you guys for watching. Make sure to subscribe to the channel and I'll see you guys in the next video. Welcome back everyone. Now that we have a good understanding of the fundamental concepts in Svelte, let's dive into the component architecture. I know we did talk about components at a very high level early in the series, but now let's go through the topic in a lot more details, as they are pretty much what you need to build medium to large scale enterprise applications. Now similar to React, Vue and Angular, Svelte follows a component based architecture. This lets you break down your application into small encapsulated parts which can then be composed to make more complex user interfaces. For example, a traditional website can be broken down into header, site navigation, main content, and footer. You can say that this particular applications have 5 components. One for header, one for site navigations, one for the main content, one for footer, and finally one component to contain every other component. The containing component is the root component, and it's usually named as app component, written in a file called app.svelte in your application. Each of the 4 nested components describe only a portion of the user interface. However, all the components come together to make up the entire application. Components are also reusable. The same component can be used with different properties to display different information. For example, the site navigation component can be the left side navigation as well as the right side navigation, only the data can change. Now how does a component translate to code in our application? Well, we have seen that bit quite a lot. A component code is usually placed in a .svelte file and contain a script section, a markup section, and a style section. App.svelte is one such example. But in real-world application, you are often going to create tens if not hundreds of components. In this video, let's learn how to create and include a new component in Svelte application. Back in VS Code, you can see that I have created a brand new project called Svelte Components. To learn all about components in Svelte in the app component which is generated for us, let's clear out the code written in the script section as well as the HTML within the main tag. It's only fair we start from scratch. Now let's create our very first Svelte component. The component will simply output a message "Hello Rahul" in the browser. So in the source folder, let's create another folder called components, which will contain all the components in our application. Within the components folder, let's create a new file called greet.svelte. This component needs to render the text "Hello Rahul." To add markup, all we have to do is just include it in the file. So needs to tag hello Rahul. Alright, we now have the HTML that needs to be rendered in the browser. But as it stands now, the HTML hello Rahul is not going to be rendered in the browser because this grid component is in no way connected with the rest of our application. So what we have to do is import this component in app.svelte and then include it in the app component markup. In the other words, we need to register the grid component with our application. So in the app.svelte, in the script section, we are going to add the import statement. Import grid from ./components/grid.svelte, which is the part to get the grid.svelte file. Now to include this grid component in app component, we specify the component as a custom HTML tag in the markup section. So within the main tag, we add the grid custom HTML tag. Now if there is no content between the tag, we can change it into a self-closing tag. Now if we save all the files and take a look at the browser, you should be able to see text hello Rahul. Your first Svelte component is up and running. So that is about components in Svelte components. Describe a part of the user interface. They are reusable and can be nested inside other components. However, we haven't quite seen how they are reusable. Let's learn about that in the next video. In the previous video, I mentioned that components are reusable. So you can create a component that returns any HTML you want to and include it in any part of your application. For example, let's say we need to reuse this grid component. All you have to do is include the grid tag as many times as you want to. If I duplicate it twice, save the file and take a look at the browser, you can see hello Rahul displayed 3 times. Although we are reusing the grid component, duplicating it 3 times like we have done here isn't really helpful, is it? What would be great is if we could pass in the name of the person we want to greet. That way we are using the same component. We could greet 3 different people instead of greeting Rahul 3 times. This is where component props come into picture. Props are custom attributes you can register on a component which allow the component content to be dynamic. Let's understand how props work in this video. Our intention here is to pass a name from the app component to the grid component and render that name in the browser. To specify props for a component, we add custom attributes to specify a name prop. We simply add the name attribute to the attribute we assign a value. Let's go with the name Luffy. Similarly, let's add the attribute on the other 2 components as well. Name is equal to Shanks and name is equal to Levi. Okay, so we are sending some data to the grid component, but how do we retrieve that value in the grid component? That is a quick 2-step process. The first step, we declare a variable in the script section using the export keyword so script tags, and within the script tag, export let name. Here name should match the custom attribute we are passing in. The second step is to bind this variable to the markup. So instead of Rahul, we use curly braces and bind name to the HTML. If we now save the file and take a look at the browser, you should be able to see hello Luffy, Shanks and Levi. Hopefully the reusability of components makes much more sense. Now that we understand props, we can define the markup and pass in the appropriate data that we want the component to use. Here, app component is referred to as the parent component and grid component is referred to as the child component. Let's add another prop to make sure we have a good understanding of how it works. I'm going to add a second attribute, hero name, and assign the appropriate value Pirate King, Yonko, and Savage. And in grid component, let's declare hero name export let hero name, and now in the markup, hello name followed by also known as hero name. Now if we take a look at the browser, you can see that output is what we expect. At the moment in our app component, we are passing in static values as props. But we can also assign dynamic values to props. That is, we can bind values defined in the script section to props in a component. Let me create 2 constants. Const name is equal to Rahul and const channel is equal to RDH code. We can now include another grid component and bind the 2 constants as props using curly braces. So I'm going to make a copy of this. Name is going to be equal to name within curly braces and hero name is going to be equal to channel within curly braces. Since the prop name and value is the same, you can specify the prop using the shorthand syntax. So just name and curly braces. If we take a look at the browser, we have hello Rahul aka RDH code. Our dynamic props works as expected. The next point about prop is specifying default values in a child component. You can assign a value to a prop. For example, Hero name, we can set it to default, and in the parent component, when invoking the last grid component, we can leave out this hero name prop. If we now take a look at the browser, you can see that the default prop value is used by the child component. Hello Rahul aka default. The last point you need to be aware of regarding props is how to spread props. Let's say we have an object with name and hero name as properties. So const object is equal to an object name is Rengoku and hero name is Hashira. If you have to grid the Hashira, you would invoke another grid component and set name is equal to object.name and hero name is equal to object.hero name. While this works, Svelte provides an easier way to provide an object as props by using the spread operator. So on the grid component, we can use curly braces and within curly braces spread object, so object. If you now take a look at the browser, you can see hello Rengoku aka Hashira, which is the output we expect. Now of course we only have two properties in the object right now, but you can probably understand the value this syntax brings to the table. When you have an object with 5 to 10 properties, instead of specifying all 5 to 10 attributes, you can simply spread the object on the component. Alright, this is pretty much the basic idea behind props and Svelte in the parent component. When invoking the child, you can include additional attributes in the child component, use the export declaration for all the custom attributes and then bind them to the markup using curly braces. Props are a key to reusing components in Svelte, so please make sure you understand them well. Alright, thank you guys for watching and I'll see you guys in the next video. Alright guys, in this video we are going to learn about the context API in Svelte. Let's begin by understanding what was the need for the context API and then understand how it works by writing some code. Consider a Svelte application that has lots of components. We have app component, which is the root component nested within the app component. At different levels are several other components. At the first level we have components A, B and C. Nested within component B is component D and nested within component C is component E. And as it turns out, component F is nested inside component E. So we have 3 levels in total. The requirement in our application is that components A, B and F are supposed to display the logged in username. That information is maintained in the app component. Now we have recently learned about components and props. Props allow us to send data from a parent component to the child component. So to display the username in the nested components, we need to pass down the username as a prop for component A. It is pretty straightforward. Directly pass it in as props for component D. However, we have the intermediate component B, so we have to pass down username as a prop to component B, and that in turn has to pass down the prop to component D. Now the scenario is somewhat similar for component F as well. The prop has to be passed through component C and then component E and then finally to component F. Even though component B, C and E do not need the prop, we still have to send the prop through them to be able to pass it to components further down in the tree. But imagine if the components were to be nested 5 or 10 levels deep. All the components in between would have to forward the prop. This especially becomes a problem for certain types of props, such as language preference, UI theme and authenticated user, which are pretty much required by many components in your application. What would be nice is if you could directly make the data available to the required component without having to manually drill down the props through every level of the component tree. This is where the context API comes into picture. The context API provides a way to pass data through the component tree without having to pass props down manually at every level. Let's understand this with the rightmost tree you see on the screen. Our goal is to pass the username value from app component and read that value in component F using the context API. There are 2 steps to implement when making use of the context API. Step 1, set the context value in the app component. And step 2, get the value in component F. To get us started, I have already created the components and nested them at the appropriate level. In app component, we have defined the username variable and set it to Rahul. The same value is rendered in the markup, and below this s2 tag, we have included component C as the child component. The import statement is within the script section. Within component C, we just have the heading child C component, and below the heading we have included component E as a child component. Component E again has a heading and component F as its child. Finally, in component f, we just rendered the heading child f component in the markup. Our aim now is to send this username value from the app component all the way down to component f and render it in the markup, all this while not using props. For step 1, which is providing a context value, Svelte provides the setContext function. Let's import it in app component. Import from Svelte the setContext function. Then after our username declaration, we can invoke the setContext function. This function accepts two arguments. The first argument is the context key. You could call this anything you want, but let's just call it username context. The second argument is the value which we want to send to all the children components of app component, that is username. Now that we are setting a context for our step 2, we go to component f and get the username context value. To get the value, Svelte provides the getContext function. So within the script section, import getContext from Svelte. Now using this getContext function, we can retrieve the username. So const username is going to be equal to getContext, and to this function we specify the same context key as an argument. Our context key is username hyphen context. Once you have the username, you can bind it to the markup. If you take a look at the browser, we see Rahul from both the app component as well as component f. Now one thing I would like to mention here is about the two arguments to set context. Right now both our arguments are string values, but there could be any data type that your app requires it to be the first argument. In fact, what is recommended is to not use a string as a context key and use an object instead. The downside of using a string is that different component libraries might accidentally use the same key. Using an object literally means the keys are guaranteed not to conflict in any circumstances, as objects only have referential equality. But this is pretty much about the context API in Svelte. It gives you a way to pass data to the component tree without having to pass props down manually at every level. Use the setContext function to provide a value from the parent component and the getContext function to consume the value in the child component. Alright then, in the next video let's talk about component events. Thank you guys for watching. Make sure to subscribe to the channel and I'll see you guys in the next video. Alright, in this video let's learn about components events in Svelte. So far we have learned about props, that is passing data from the parent component to the child component. Sometimes though you might also want to communicate from the child component back to the parent component. This is where custom events come into picture. Let's understand the syntax and usage in this video. For our example, we are going to consider the scenario of implementing a pop-up. Of course, to keep it simple, we will not create a pop-up component with all the styling and markup. We will create a simple div tag with some content and assume it as a pop-up component. Let me explain the scenario before we dive into the code. In our app, we have the app component. This component will have a button to open the pop-up. The pop-up is a simple component with an if block to conditionally display it in the browser. So on click of this button, we will show the pop-up component. In the pop-up component, we will have some text and a close button. On click of the close button, we have to hide the pop-up component. Straightforward requirements. So let's head over to VS Code and implement this. Let's begin by creating a new file in the component folder. The file name is popup.svelte. For the markup, add an s2 tag that says this is a pop-up. After the text, let's also add a button whose text is close pop-up. Let's include this pop-up component in app component. So in the script section, import pop-up from ./components/popup.svelte. And in the markup, add the component as a custom HTML tag pop-up. At this point of time, the pop-up will always be visible. Let's add a variable to conditionally render it. Let's show pop-up is equal to false and then wrap the component with an if block where the expression depends on show pop-up being true. So curly braces, hash, if show pop-up and then close the if block. Since show pop-up is initialized to false, the pop-up is hidden on page load. Let's add a button to set show pop-up to true. So before the if block, add a button. The text is going to be show pop-up, and on click of this button, you are going to have an arrow function where we set show pop-up is equal to true. If we now save the file and head to the browser, we have the button being displayed. I click on the button and the pop-up component is displayed. The component has an h2 tag and a button. Now what we want is on click of this button, hide the pop-up. We know that to hide the pop-up, we need to set show pop-up to false. However, the property is present in the app component, whereas the close button is present in the pop-up component. So what we have to do is to send a message from the pop-up component to the app component, asking the app component to set show pop-up value to false. And the way we do that is using custom events. Let's see how. In the pop-up component, we begin by importing a function from the Svelte library. So add a script tag and import from Svelte create event dispatcher after importing. We call the function. As the name indicates, the function creates an event dispatcher. So let's assign the result of calling this function to a constant called dispatch. The dispatch function can now be utilized to send events from this pop-up component to the parent component, which in our case is the app component. So on click of this close pop-up button, we are going to dispatch the close event. We can name this event anything we want, but close seems appropriate for our pop-up. Now that we are emitting an event from this pop-up component, let's listen to it in the app component. To listen to the close event, we again use the on directive. So on colon, but this time the event is a custom event instead of a DOM event. And the event name is close. As a handler, we are going to set show popup to false. So when the child component emits the close event, we are setting show popup to false, as simple as that. If we now go back to the browser, click on show popup, the component is displayed. And if I click on close popup, the component is hidden. This is pretty much how you communicate from the child component to the parent component through custom events. Now there is one point I would like to make note of regarding dispatching events from a component. At the moment, we don't have to send any data to the parent with a custom event, but you might come across such a scenario. So let me quickly show you how to pass data along with the event. In the pop-up component to dispatch, we specify a second argument, which would be the data. It could be any data like a string, object, and so on. But let's simply send a string value Rahul as the data for this example. Now in the app component, let's move the close event handler to a function. Call the function as close popup, and this function now receives an argument which is the event object. In the function body, set show popup to false, and then to access the data we are sending from the popup component, we need to access event.detail. Let's simply log that to the console. On close is now going to be equal to close popup. If we now go back to the browser, open the console, open the popup, and click on close popup, you can see Rahul in the console. This is the data we sent from the child to the parent component. Alright, to summarize custom events, import the create event dispatcher function in the child component and obtain the dispatch function by calling it. Using the dispatch function, emit an event by passing in an event name and any event data. In the parent component, listen to the custom event using the on directive and assign the appropriate handler. The data can be retrieved using event.detail. Alright, thank you guys for watching. Don't forget to subscribe to the channel, and I'll see you guys in the next video. In the previous video, we learned about component events. In this video, let's learn about a related topic, which is event forwarding. Event forwarding is a concept that is needed if you want to listen to an event on a deeply nested component. Let's understand with a simple example. In the components folder, I am going to create two new files called inner.svelte and outer.svelte. In the app component, I am going to import the outer component and include it in the markup. Import outer from ./components/outer.svelte, and in the markup specify the outer component. In the outer component, I am going to import the inner component and include it in the markup. So script tag import inner from ./inner.svelte, in the markup include the inner component. Finally, in the inner component, I am going to add a button with the text greet. So our inner component is now sort of deeply nested component in our component tree. Here is what we want to achieve. On click of this greet button, we want to dispatch an event to the app component, which will then listen to the event and greet the user with a simple alert dialog. Let's see how to do that. First, let's handle the button click. So on click, and we assign a function called greet. Next, add a script tag, and within the script tag define the greet function. Within the function body, we need to dispatch an event called greet with the data as a string hello. So first import from Svelte create event handler dispatcher. We then call it and assign it to a constant called dispatch. Within the function body, we call dispatch. The event name is going to be greet and the data is a string hello. So we are now dispatching the greet event from this inner component. we can go to the outer component and listen to this event. So inner on greet, and we could assign a handler with a pair of curly braces. However, we don't want to handle this event in the outer component. Perhaps we have all our logic in app component and we want the greet handler as well to be in the app component. So we need to basically forward this greet event from the outer component to the app component. And how do we do that? Well, we could import create event dispatcher again and dispatch the same event with the same data. But that seems like duplication, and it definitely is. Luckily, Svelte provides a very simple way to forward an event to the parent component, and that is to simply omit the event handler. So if you don't assign a handler, Svelte considers that greet event has to be forwarded to the parent component. All we have to do now is head over to the app component and listen to the same greet event. So on the outer component on greet, and let's assign a handler called handle greet and define the function in the script section. So function handle greet, we get the event. We are going to alert event.detail, save all the files, head to the browser, and you can see on click of the button, the alert dialog pops up with the message hello. Now it's also worth noting that event forwarding works with DOM events as well. So let's say we create a button component with custom styling. So new file button.svelte, and let me copy paste the code which includes some stylism. You can see that we have a button and style for that button, but we don't want this button to define what happens when the user clicks it. We want the parent to define the behavior. So we simply forward the click event by not specifying a handler in the app component. We can now import the button component and perhaps specify an inline handler. Button, the text is going to be click, and the onClick handler is going to be an arrow function which alert clicked. Take a look at the browser and the button works as expected. So that is about the concept of event forwarding in Svelte. Comes in handy when dealing with nested components, when you have to listen to deeply nested component events. Alright, in the next video let's take a look at another cool feature, which is slots. Thank you guys for watching, and I'll see you guys in the next video. Alright, in this video let's move on to the next concept in Svelte, which is slots. A few videos ago we learned about props, which allow you to reuse components by passing in different data. Although props are great for reusability, we do have a strict parent-child relationship. The child will always be in control of the HTML content, and the parent can only pass in different data values. Slots on the other hand are more powerful, similar to props. They allow you to reuse a component, but they also allow the parent component to control the content inside the child component. In other words, slots allow a parent component to embed any content in a child component, including HTML elements. Let's understand its syntax and usage with an example. Let's begin by creating a new file in the components folder. I'm going to call this card.svelte. As you might have already guessed, we are trying to create a card component, which is a pretty common UI element. When building web applications, it's a component that's reused quite a bit in any project. For our card component, I'm going to begin by adding a div tag with a class equal to card. Within the div tag, I'll simply add some text, card content. I'm going to paste some styles for this card class. So one for card and one for card hover. And that pretty much is our card component. Let's include it in app component. Import card from ./component/card.svelte, and within the main tag card. If you now save the file and take a look at the browser, we should see the card component being displayed. Now this is great, but we want the content to be dynamic. So let's pass in a prop instead of having the static text inside the div tag. In card.svelte, add the script tag and declare a prop using the export keyword. Export let content, bind the same to the markup. Instead of the static text in the app component, we can now pass in the content prop. Content is equal to card content 1, and I can make a copy of this card component and pass in the content prop as a card content 2. If you now save the file and take a look at the browser, you should be able to see both the cards with different content. Now this is better, but we still have a strict parent-child relationship. At the moment, I can pass in a string to the card component and that will get rendered. But what if I wanted to pass in a h2 tag, or what if I wanted the card content to be an image instead of simple text string? This is where slots come into a picture. Let's understand how to use slots. Begin by getting rid of the prop we have just added. Now inside the div tag, we add a slot tag. In the parent component, remove the prop and instead add a closing tag for the card component. Now in between the opening and closing tags, we can specify any content we want to, and it would replace the slot tag in the child component. For our first card, let me add some simple text, card content. For the second card, let me wrap the same content with an s2 tag, and for the third card, let me add an image as the card component. If we now save the file and take a look at the browser, you can see that we still have the styles that reflects a card, but the content inside is controlled by the parent component. So to reiterate, Svelte will take the content in between the opening and closing tags of the card component and substitute it in place of the slot tag. We add text, a heading, or even an image. It's also possible to specify default slot content if the parent component does not specify any. So in card.svelte, in between the opening and closing slot tags, I can add default content, and in the app component add another card tag. For this time, without any content between the opening and closing tags, if we take a look at the browser, you can see that the default content is rendered. This is pretty much the basic usage of slots. As you can see, slots give you greater control in terms of reusing and composing new components in Svelte. We do have a few more details about slots, so let's talk about them next. Thank you guys for watching. Make sure to subscribe to the channel, and I'll see you guys in the next video. In the previous video, we learned about slots. We created the card component which contains a slot in the template. This allowed us to send arbitrary content from the parent app component. Although this works great, sometimes you might find it useful to have multiple slots. By doing so, you still have some predefined structure in the child component. But the content within that predefined structure can still be controlled from the parent component. This will also reduce the code you write if you have to utilize the component in multiple places. A very good example is a layout component, which is definitely applicable to our card component as well. In this video, let's understand how to add multiple slots to our card component. So, back in VS Code, in card.svelte, let's add some structure to our card component. Our card should contain a header, a content, and a footer. So let's add 3 div tags with an ID that represents the section. A card header section, a card content section, and a card footer section. For each of the 3 sections, we want the HTML to be controlled by the parent. So we need a slot again. Let's add one each inside the 3 div tags. But now we have 3 slots. Svelte will not know which slot the content has to be placed in. So when we have multiple slots, we need to specify a name for each of the slots. For the card header slot, let's add name is equal to header. For card content slot, name is equal to content. And for the footer slot, name is equal to footer. For the content slot, you could specify a fallback content if you want to. Now let's go back to app component and fill in the new slots begin with the card component. Within the opening and closing tags, we specify the content to be placed in each of the slots. And the way to do that is using the slot attribute. So add a div tag and the slot attribute which will contain the name of the slot it has to replace. First we have the header slot, so a div tag and a slot is going to be equal to header. As the actual content that goes into a child component, let's simply add an s3 tag that says header. Next, let's add a div tag for the content slot. So div tag, the name of the slot is content, and for the actual content, let's add an image. Finally, let's add the footer content. So the tag slot is equal to footer, and as the footer content, let's add a button that says view details. Again, this is just to demonstrate multiple slots, so you can add any HTML that you want to. If you now save the file and take a look at the browser, you can see a card component with a header, content, and a footer. Our multiple slots card component is working as expected. This card doesn't justify a practical card component, but in real-world application you can consider the header having a background and font color, the footer being right aligned to place the action button, and so on. Another possible use case is a model component. You would have a model header, model content, and a model footer. The layout is fixed, but what goes within each of the sections in the layout can be controlled from the parent component by specifying slots in the model component. One more feature Svelte provides related to named slots is the ability to check if the slots has been defined by the parent component. Let's say, just before the footer slot we have a horizontal line. In the browser we can see the separation, But it might so happen that another card component might not really need the card footer. So in m.svelte, if I remove the footer content and head to the browser, we still have the horizontal separation. But that was only necessary if the footer slot was defined. To fix this, we can conditionally render the slot in the card component. We achieve that using $sign slots, which is a special object provided by Svelte. The object contains slot names defined by the parent, which we can use to conditionally render the slot in the child. So for the footer slot, we are going to use an if block, so #if. The special object is $sign slots, and we check if the footer is present. The horizontal rule, of course, will now be within this if block. After the div check, close the if block. You are basically asking Svelte to render the footer slot only if the parent is defining the footer slot in the markup. If you now head back to the browser, the horizontal rule doesn't show up, and our card component looks much better. So that is about name slots and the $sign slots objects, which comes in handy, and there is one final detail left about slots that we need to learn. Let's do that in the next video. In this video, let's learn about slot props. And this again is a concept that is best understood with an example. So let's dive into the code straight away. I'm going to create a new file in the components folder. Let's call it namelist.svelte. As the name indicates, the component is responsible for displaying a list of names in the UI. Let's implement this component in the script section. I'm going to copy paste a list of names, which is an array of objects. Each object has a first name and a last name. We have Monkey D. Luffy, Akagami Shanks, and Levi Ackerman. Our next step is to bind these names to the markup. Since we have a list of names, we need to use the each block. So in the markup, add an each block. The source is names, and in each iteration we refer to the object as name and specify name as the unique key as well. Within the each block, I'm going to add an S3 tag rendering name.firstName and name.lastName. Now that the name list component is done, let's include it in app.svelte. Import it in the script block and add it to the markup. Let's also comment out the card component from the previous videos. If you now save the file and take a look at the browser, we have the list of names being displayed. And what we have here is great. However, let's say we need to display the list of names in other parts of our application. In some pages, we might just have to display the first name, and in other pages, we might have to display last name followed by first name. Basically, we want the parent component to control how the child component will render the content. I'm pretty sure you would have guessed by now, but this seems like a perfect use case to use slots. Let's go back to VS Code and make the changes. In namelist.svelte, instead of rendering first name followed by last name, let's add a slot in between the opening and closing tags with name is equal to hero. So this is a slot to render the hero name back in app component. Let's specify the content for the slot. So instead of self-closing tag, we need the opening and closing tags for this name list component. In between the tags, we can specify the format the name should be rendered in. However, you might have realized that we have come across a problem. The name object in each iteration is present in the name list component. It is not present in the app component, so we need a way to send name as data to the parent component. And in Svelte, we use what is known as slot props to achieve that. It is pretty similar to props, but we are applying them on a slot within a component. The syntax is pretty simple in name list component on the slot. We are going to add two props to send the first name and the last name to the parent component. For first name, add a prop called first name, and to the slot drop, we have assigned name.firstName. Similarly, let's add another slot prop called last name and assign name.lastName. Now that we are sending data to the parent, let's head over to the app component and use these props. I'm going to add an S2 tag between the name list opening and closing tags. Now first we need to indicate to Svelte that this template belongs to the slot in our name list component, for which we need the slot name. In our example, it is hero. So add the slot attribute and assign hero. Now slot props for this slot can be obtained using the let directive. So on the S3 tag, let colon first name and let colon last name, which means as part of the S3 tag content, we can now bind first name followed by last name. I can also make a copy of this and render last name followed by first name, or make another copy and render just the first name. If you now save the file and take a look at the browser, you can see that the list of names are being displayed as expected. In each of three cases, we have Monkey D. Luffy, Akagami, and Levi Ackerman. In each of the three cases, the logic to render a list of names is the same, but the way we display the list of names is now controlled by the parent component through slots, which as you can see gives us more flexibility. In the way we display the data to summarize about slot props in the child component, on the slot tag pass some data to the parent component. In the parent component, use the let directive. This gives you access to the slot props for that particular slot, which you can then use to structure the template as you want to. With that, we come to the end of the discussion about slots in Svelte. Thank you guys for watching. I'll see you guys in the next video. Welcome back everyone. In this video, we are going to go over one of the more fundamental concepts when it comes to component architecture in Svelte, and that is global versus scoped styling. There are 2 points to understand, and we will go over each of them with an example. But first, let's set up our components. I'm going to create a new file in the components folder, childstyles.svelte. In the component markup, I'm going to add an h4 tag with the text childstyles component text. Next, I'm going to include this component in app component. So import childstyles from /component/childstyles.svelte. Included in the markup, childstyles. Now above this component, I'm also going to add an h4 tag. The text is app component text. So we have an h4 tag in the app component, and the child styles component. Our setup is done. Now let's begin with our first point, which is about scoped styles in the app component styles section. Let's add the color orange to the h4 tag. So h4 color orange. If you now save the file and take a look at the browser, you can see that the orange color is restricted only to app component. So the first point to make note of is that in Svelte, by default, a component style are scoped to that particular component. Even if the component has children components, this allows the child components to define their own styles. So in child styles component, I can add a style section and specify a different color. For the h4 tag, color is olive. Take a look at the browser and we see 2 different styles. Now if this is the case, how do we apply global styles in Svelte application? After all, there would be styles that we want applied for every component in the application. Well, that brings us to the second point, to apply styles to a selector globally. You can use the global modifier to demonstrate its usage. Let's add an h3 tag in both the components, app component global style and child styles component global style. Now in the app component styles, we can use the global modifier specifying the selector and its corresponding styles. Let's set color to blue. If you now take a look at the browser, you can see both the h3 tags are blue colored in app component as well as the child styles component, and this is because of global modifier we have used. You can remove this style from app component and paste it inside the child component, and the result is same. Blue color is applied globally. The 2 points is to keep in mind. By default, component styles are scoped to the component. However, styles can be applied globally using the global modifier. Alright, I hope you now have clear understanding of component styling in Svelte. Thank you guys for watching, and I'll see you guys in the next video. In this video, let's have a theoretical understanding of components life cycle hooks. A component's life cycle refers to the different phases a component goes through in a Svelte application. Life cycle hooks are functions that allow us to run code at key moments during that life cycle. There are a total of 5 life cycle hooks that we can use in component. Let's understand the details at high level. The first of the 5 hooks is the onMount hook. The onMount hook schedules the passed-in callback to run as soon as the component has been mounted to the DOM. Also, if you return a function from the callback function, that function will be called when the component is unmounted. The onMount hook is probably the hook which you will use the most in your component. It is in this hook that you would make HTTP requests, perform DOM manipulations, and set up timers or even listeners. The second hook is the onDestroy hook. This hook schedules a callback to run immediately before the component is unmounted. So you could perform tasks like clearing timers and removing event listeners. Now you can do that in the onMount hook as well by returning a function from onMount. But the difference is when it comes to server-side rendering, onMount does not render inside a server-side component, whereas onDestroy does. The third hook is the beforeUpdate hook, which schedules a callback to run immediately before the component is updated, after any state change. Similarly, we have the fourth hook, which is the after update hook, which schedules a callback to run immediately after the component has been updated. Both these hooks can be used to access the existing DOM before and after an update. The last hook is tick, which returns a promise that results once any pending state changes have been applied. The tick function is unlike other lifecycle functions in that you can call it anytime and not just when the component first initializes. You might not use this hook too often, but it does help when you want to run some code after pending changes have been applied to the DOM. So that pretty much is the theoretical overview of the different lifecycle hooks in Svelte. Out of the 5, the onMount lifecycle hook is something you would use the most in your application, which is why we have to learn about its practical usage. So in the next video, using the onMount hook, let's learn how to make HTTP requests in Svelte. Okay, so I'll see you guys in the next video. In the previous video, we learned about the different lifecycle hooks in Svelte. In this video, we will use the onMount hook to learn how to make a GET request on page load and render the fetched data in our Svelte component. To fetch the data, we need to have an API endpoint. For that, I will be making use of JSON placeholder, as you can see here. It is basically a free-to-use fake online REST API for testing and prototyping. I want the whole focus to be on data fetching in our Svelte application and not on creating an API. JSON placeholder saves us from having to create the API ourselves. I'll leave a link to this site in the description down below. Now if you scroll down to the root section, you can see the possible HTTP requests you can make. For this video, I'll be making a GET request to /posts, which will fetch an array of posts to display in the UI. So let's get started and create a new component within the component folder. Create a new file called postlist.svelte. Let's begin with the script section. We know that we need to fetch a list of posts and render it in the UI. For that, let's declare a new variable called posts and set it to an empty array. So let post is equal to an empty array. Next, let's make the actual API call. The place to make our API call is in the onMount lifecycle hook. So at the top, import onMount from Svelte and then we call the function. onMount accepts a callback function and this callback function is responsible for making the API call. Let's make this async. Within the function, we are going to use the fetch API to make a GET request to the JSON placeholder API. Now to make a GET request, we invoke fetch and pass in the API endpoint assets argument. So const response is equal to await fetch and back in the browser, copy the URL and paste it. Alright, we are now making a GET request. The fetch API returns a promise, which is why we have added the await keyword. This is nothing specific to Svelte and is simply modern JavaScript. Now once the response is retrieved, we need to convert it into a JSON format that we can use in our component. So await response.json and we assign this value to our posts variable. Let's log this post to the console to see the data that we have fetched. If we now include this post list component in our app Svelte and head back to the browser, you should see an array logged in the console. If I expand it, you can see the list of 100 posts that have been retrieved. Each post has an ID, a title and a body property. All that is left now is to render it in the markup. So back in VS Code, we are going to use the each block to render the list of posts. So in the markup section, each post as post and the unique key is going to be post.id. Let's also close the each block. Within the each block, inside an h3 tag, we are going to render post.id followed by post.title. Let's also add a paragraph tag and render the body. Post.body, let's add a horizontal line to separate the different posts. Now save the file, go back to the browser and you should be able to see the list of posts are fetched from the API and displayed in the browser. The blue color of course is from our styles video where we style the h3 tag. Now let me also mention another cool feature about the each block. Between the opening and closing line of the each block, we can add an else block which automatically renders if the data source length is 0. So we can add curly braces, else and a paragraph tag that says loading. Now back in the browser, we can head over to the network tab and set the speed to slow 3G. Refresh and you can see the loading text. till the API call completes and the data is fetched pretty neat. If you ask me so, this is pretty much how you make an HTTP request in Svelte. Let me explain how this complete process happens, as it is really important to understand. When the component initializes, the post variable is set to an empty array, and onMount hook is executed at this point. The post array is empty and the markup renders to the loading text. In the background, the fetch API sends an HTTP request to the JSON placeholder. In point, the data is fetched and assigned to the post array. If the component state updates, the component will re-render the post property contain 100 items, which we iterate over using the each block, and in each iteration we bind the post ID, title and the body to the markup, which is then rendered in the browser. So you have successfully used the onMount lifecycle hook for making HTTP requests. In the next video, let's look at another practical usage of the onMount lifecycle hook. In this video, let's learn about the concept of this binding in Svelte. Basically, this binding makes it possible to access DOM nodes directly within Svelte. For our understanding, we will take a look at one of the more common use cases, which is focusing a text input. For example, if we have a login form on page load, we want the username input field to be focused. Let's see how to achieve that with this binding and the onMount lifecycle hook. I'm going to start off by creating a new file in the components folder. So autofocus.svelte. Now in the markup, I'm going to add an element. Input type is equal to text. I will import this component in app component and add it to the markup. So import autofocus from ./components/autofocus.svelte and within the main tag autofocus. Now if we save the files and take a look at the browser, you should be able to see an input field. What we want to achieve is, as soon as the page loads, the input field should be focused. We can do that in two simple steps using this binding and the onMount lifecycle hook. The first step is to declare a new variable in the script section and bind it to the input element using the bind directive. So script section, we are going to declare a variable called input_ref. On the input element, let's add this binding using the bind directive. So bind:this. To this we assign the variable we have just declared. Input_ref, we now have a reference to the input element. The second and final step is to call the focus method on this input element, and the place to do that is the onMounted lifecycle hook. So from Svelte, import the onMount lifecycle hook and invoke it. If you can recollect, this method is the place to access the DOM element. onMount accepts a callback function and within the function body on the element reference, which in our case is the input_ref. We can call the focus method, so .focus. If we now save the file and take a look at the browser, refresh, input is focused on page load. The read-only this binding applies to every element and allows you to obtain a reference to the render elements. Alright, that is a quick note about this binding in Svelte. Thank you guys for watching, and I'll see you guys in the next video. In this video, we are going to learn about dynamic components in Svelte. Dynamic components is a concept that is best understood with some background. So let's first understand the scenario we are looking at implementing for our example. In a web application, you might often need to create a tabbed user interface. For example, you would have 3 tab buttons. At the top and below the tab you would have some content, but the content is controlled by clicking on the individual tab buttons. If you click on the tab A button, tab A content is displayed. Click on tab B button, the corresponding content would be displayed. And if you click on tab C button, the corresponding content again would be displayed. Let's try to implement this in our Svelte application. I'm going to begin by creating 3 new components in the component folder. Tab A.svelte, tab B.svelte and tab C.svelte. Within the tab A.svelte file, let me add some text as markup. Tab A content, and I'm going to copy paste this code into the other 2 files as well, tab B and tab C. Next, let's add the tabbed user interface in the app component first. Let's import all the 3 components, tab A, tab B and tab C from their corresponding files. Next, let's add the app component markup for the tab buttons. Let's add 3 buttons, tab A, tab B and tab C. Next, let's invoke the 3 components. Alright, if we now save the file and take a look at the browser, we have the tab buttons, but all the three components are being rendered as the content. Let's go back and make changes to ensure only the active tab is being displayed. In the script section, add a new variable called active tab and set it to tab A. Select active tab is equal to tab A. On each of the buttons on click, let's update the active tab. So on click, active tab is equal to tab A. Similarly, active tab is equal to tab B and active tab is equal to tab C. Finally, on the individual components, let's add a condition. If active tab is equal to tab A, render tab A component. If active tab is equal to tab B, render tab B component. And finally, if active tab is equal to tab C, render tab C component. So the appropriate tab is rendered based on the active tab value, which is controlled by the button click. If we now save the file and take a look at the browser, by default, tab A is the active tab and its content is displayed. Click on tab B and the content changes, and the same with tab C as well. We are able to change the content based on the active tab. Although this works great, but you will start to realize that this is not the right approach. If we have a lot of components that we have to switch between, you would need to include every single component in the markup, and for each component, add the if block to conditionally render it. For example, if you have a multi-step form where each form is presented under a tab, it is quite possible that you might have 8 to 10 tabs easily. To help in this scenario, Svelte provides us with a special element. Let's understand its syntax and usage. Let me comment out the component tags to begin with. Next in the markup, we are going to include a Svelte specific HTML tag, which is Svelte:component. The role of this tag is to render a Svelte component, and the way we inform this tag what component to render is by setting this attribute to the attribute we bind a component. For our scenario, the component has to be dynamically set based on the button click. So begin by changing active tab to reference the actual component rather than the string. Tab A, tab B, and tab C. Without the quotes in the script section, the initial value is the tab A component. Now to this attribute on the Svelte:component special element, we assign active tab. We now save the file and take a look at the browser. Our UI still works as expected, but this time we have written lesser code. So that is about dynamic components in Svelte. When you have a requirement to switch between components, you can make use of Svelte:component special element with this attribute to inform Svelte of the component that has to be rendered in the UI. Dynamic components also reduce the amount of code you have to write, thereby making it easier to maintain your code in the long run. One last point I would like to mention here is about special elements in Svelte. In this video, we had a look at Svelte:component element, but let me tell you that it isn't the only special element available to us. We have a few others, which I want to talk about very briefly in this video. We have Svelte:self, which allows a component to contain itself recursively. We have Svelte:window, which lets you add event listeners to the window object, and Svelte:body, which lets you listen for events that fire on the document body. We then have Svelte:head, which allows you to insert elements inside the head of your document. Lastly, we have Svelte:options, which lets you specify compiler options. The Svelte:component element is something I feel needed a bit of explanation for practical usage, and hence this video. The use case for the other special elements is very specific, and you might not often require them in your application. So I wanted to ensure you are aware of these elements. But please do explore yourselves their usage based on the app requirements. Alright then, thank you guys for watching, and I'll see you guys in the next video. Welcome back everyone. In this video we are going to learn about module context, which lets us share code across component instances. This again is a concept that makes sense only when we have an example to work with. So let's dive into the code straight away. In the component folder, I'm going to create a new file called counter.svelte. Within the file, I'm going to implement a simple counter. Add a script section, declare a variable called count initialized to 0. In the markup, let's display the count value as to tag. Count is within curly braces. The count variable, let's also add a button to increment the count value. So button, the text is increment, and on click of this button, let's add a handler called clickHandler. Define the function in the script section, so function clickHandler, and within the function count plus equals 1. Now that we have the counter, let's import it in app component. Import counter from ./component/counter.svelte. In the markup, let's invoke the component 3 times. Let's save all the files and head to the browser. On page load, we should see the 3 count values and 3 increment buttons, each pair corresponding to one instance of the counter component. What is important to notice here is that each component instance maintains its own count state. If I increment counter 1, its value increments. The remaining 2 counters are unaffected, and this is the case with the other 2 counters as well. For a majority of your components, this is all you ever need. But if at all you come across a scenario to share code across the component instances, for example to maintain some data synchronization across all the instances, you can make use of module context. We can achieve this code sharing by declaring another script tag, but this time with context is equal to module specified on the tag. For our example, let's track the total count for all the counter instances. So script tag, but this time context is equal to module, within the module context as we can call it. Let's declare another variable called total count and initialize it to 0. In the click handler though, apart from incrementing the count value, we can also increment the total count value. Total count plus equals 1. Next, we are going to create a getter function for this total count value. So export function get total count, and within the function body we return total count. This function can be invoked in the counter component itself. But since it is shared, a better place would be to invoke it once in the app component. This is the reason you see the export keyword back in the app component. We can now import it. So import counter and get total count from counter.svelte. And in the markup, we can add a button that simply alerts the total count value. So button alert total count is the text, and on click of this button, you're going to alert get total count. And make sure to include the parentheses. If we now save all the files and head back to the browser, we see the alert button and the 3 counters. Initially, if I click on alert total count, we can see the value is 0. Let's now increment the first counter by 3, get total count, and now it is 3. Increment the second counter twice and the count value is 2, but the total count value is now 5. So the total count value is being shared across the counter components. Increment the third counter by 5 and the total count is now 10. So if you want to share code across the component instances, you can make use of the module context. Now one point I would like to mention about module context is that the variable defined in module scripts are not reactive. We are assigning a value like we have done here for total. Count will not trigger a component to re-render, even though the variable itself will update. So if you were to get rid of the local count value and render total count instead of count, go back to the browser, the total count is rendered. However, which increments the total count, the component does not re-render. If we get the total count from the getter function, the value has been updated as you can see. So to repeat myself, defined in module scripts do not re-render the component when a new value is assigned to them, which raises a very important question. What if we want to share values between multiple components but ensure the component re-renders to reflect the updated value in the browser? Well, the answer to that question is a concept called stores in Svelte. What are stores and how do they work? Let's take a look at that in next few videos. Alright, thank you guys for watching. I'll see you guys in the next video. Welcome back everyone. In this video, let's understand about stores in Svelte. If you are coming from React or Vue background, Svelte stores is similar to React Redux or Vue.js. So you might have a fair idea about what they are. However, if you don't have a React or Vue background, there is nothing to worry about, as I'll be explaining in simple terms the what and why about Svelte stores. Let's start with why, which will then help us understand what exactly Svelte stores are. Consider a Svelte application. The application may consist of several components nested at various levels. Let's pick a component at the end of component tree. So component A. This component has the input field to access the username, which is stored locally in the component script section. Seems pretty straightforward. Now it just so happens that a sibling component, which is the component B, needs to display the username. Now how do we send the username from component A to component B? A good approach is to move the name variable to the parent component, which is C. Component C then provides data as props to component A and can accept custom event from component B to change the name. What is if few days down the road that component D also need to display the username? The solution is again to lift the state up. State here refers to the data we are maintaining, which is the name variable. The state is now managed in the parent component E, and the very next day all of a sudden you find state here refers to the data we are maintaining, which is the name variable. The state is now managed in the parent component E. The very next day all of a sudden you find out that you need to display the username in component F. Now the only choice you have is to lift the state to app component. As you see, managing state in Svelte is definitely not as simple as it seems. So in Svelte application, where you have a considerable number of components which share some common state, state management could become troublesome. This is where stores will help you out. With stores, your state is contained outside your component hierarchy. If component A wants to update the state, it communicates with the store. The store updates the state and then sends the value to the components that are in need of that value. How does this happen? Well, we understand that when we are coding. At this point, you might be thinking, doesn't the context API solve the problem? Well, it sort of does. But the store module in Svelte lets you organize code in a much better way, and the state change is more predictable, since the store exposes the method that can alter the state value. If you are still a bit confused, stick with me for next few videos and it will start making sense. But now that we understand a bit about the scenario, we can answer what are Svelte stores. In Svelte, stores are a feature which lets us share state across multiple components, which are not necessarily in the same component hierarchy. You could say stores help you manage global state in a Svelte application. So in the next video, let's understand with an example how to work with Svelte stores. In this video, let's learn how to create and use a store in Svelte. Now before we dive into the code, let's understand the scenario we are looking to implement in our Svelte application. We want to implement a simple counter. The counter should have a button to increment the counter, a button to decrement the counter, and a button to reset its value. And of course, we need to display the count value in the browser. The scenario is very simple, as you can see. You could definitely implement this with a single counter component. However, we are here to learn about stores. So we are going to assume that each of these functionalities are contained in separate components. So the count value needs to be shared across 4 different components, which seems like a perfect use case for stores. Let's head back to VS Code and understand the code needed to implement this scenario. We are going to do this in 5 simple steps. The first step is creating the count store in the source folder. I am going to create a new folder called store. Within the folder, I am going to create a new file called stores.js. Within this file, we create our count store. For that, we first import a function called writable from the Svelte/store module. So import writable from Svelte/store. In the next line, we call the function to create a store. Let's assign the value to a constant called count. And the initial value of count will be 0, which we can pass into the writable function as an argument. And there we have it. We have created our very first store in Svelte. Let's export the store to use it in the other 4 components. Alright, now that we have our store, let's proceed with step 2, which is creating a component to display the count value. In the source folder, I'm going to create a new folder called components. And within the components folder, I'm going to create a new file called display. So display.svelte. In this file, we create a component that renders the count value to the browser. So add a script section and import the count stores from stores.js. So import count, which is what we exported from /store/stores. Once we have the store imported, we need to subscribe to its value. We do that using the subscribe method on the count store. So count.subscribe, and this accepts a callback function. The function receives the count value as its argument, which we can then assign to a local variable in the component. So let's create a local variable called counter. And within the callback function, assign counter is equal to value. We can then bind this counter variable to the markup. So as to tag, current count is counter. Let's now include this component in app component. So import it at the top and then head to the browser. We should be able to see the initial count value, which is 0. Let's now proceed to step 3. For step 3, we are going to implement the increment functionality in the components folder. Create another file called increment.svelte. Within the file, we add a button with the text increment. And on click of this button, assign a handler called increment. Now we implement this handler. add a script section, and within the script section we define the function. So function increment, and within the function body we need to increment the count value. And the way to do that is to use the update method on the count object. So begin by importing count from the stores. Import count from store/stores. Now within the increment function we call count.update, and this function accepts a callback function as its argument, which receives the current count value as its argument. All we have to do now is return the same value after incrementing it by 1. So return value plus 1. Our increment component is ready. So let's include this in app component. So import it at the top and head to the browser. You can see that we have the button, and when we click on it, the count value updates to 1. What happened here is that the subscribe method in the display component ensures to count value is updated in the component, which then causes a re-render and we see 1 in the browser. So we can use the update method to update the store values. For our step 4, let's add the decrement functionality by making modifications to the increment functionality. In the component folder, I'm going to create a new folder called decrement.svelte. I'm going to copy the code from the increment component and paste it here. The button text is going to be decrement, the handler is going to be decrement, and we return value -1. Let's also import this component in app component and include it in the markup. So save the file and head to the browser. You can see that the decrement button works as expected. Now for the 5th and final step, let's add the reset functionality again by making modifications to the increment functionality. So in the component folder, I'm going to create a new file called reset.svelte. I'm going to copy the code from increment component and paste it here. The button text is reset and the handler is going to be reset as well. But this time, instead of using the update method, we can use the set method since we don't need the current value of count. So count.set, and we pass in 0. Let's import the component in app component and include it in the markup. Save the file and head back to the browser. If I click on reset, the count is factory 0. The counter scenario where you set out to implement has been completed. Let me quickly go through what we have done. In the stores file, we created a count store using the writable function from the store module. The initial count is set to 0. Read the count value. We use the subscribe method on the count object to update the count value based on its existing value. And finally, to set a specific value, we use the set method. Hopefully you have the big picture of how store works in Svelte. Now there is one final detail that we need to look at. At the moment in display.svelte we subscribe to the count value, but you might have noticed that we never unsubscribe it. If the component was instantiated and destroyed many times, this would result in a memory leak. We can fix this by using the onDestroy lifecycle hook. So import onDestroy from Svelte, assign count.subscribe to a constant, and then pass that into the onDestroy function. The unsubscribe function gets called when the component is unmounting from the DOM. Now although this works perfectly fine, you will soon realize that this pattern gets repetitive. Every time we need to display a store value, we need to subscribe and then unsubscribe in the onDestroy hook. To help us with this boilerplate code scenario, Svelte provides a special syntax. You can reference a store value by prefixing the store name with a $sign. So we can remove the local variable onDestroy, the subscription and the unsubscribing logic. And instead we just have to include $count, so store value prefixed with a $sign. Now Svelte will automatically manage the subscription, head back to the browser, and everything works as expected. The code, however, is simplified to a great extent. So this is pretty much the basics about Svelte stores. Let's look at a few more concepts around the same topic in the next video. Thank you guys for watching, and I'll see you guys in the next video. In the previous video, we learned how to create a store using the writable function. Such a store is called writable store, which implies you can read and write values to a store. But sometimes you might not want other components to be able to update the store value. You still want the value to be shared across the components, but just not allow the components to update the value. In such cases, you can make use of readable stores. To understand readable stores, the example we are going to consider is displaying the current time in the browser. Let's say you are building an app where you need to display the current local time. So the time has to be shared across multiple components, but you don't want any individual component to update that value. In other words, you need the readable stores. Let's understand the syntax and usage. In the stores file, we create a readable store for which we import the readable function. So import writable comma readable from Svelte store. Let's call this store as time. So const time is equal to readable. The initial value is going to be a current date. So new date, although the store is readable, it doesn't mean we cannot update it. The readable function accepts a second argument, which is a callback function. This function receives a function called setAssets argument, which we can use to update the time in the callback function. Let's create a timer to set time every second. So const interval is equal to set interval, and this accepts a callback function. We also set the second argument, which is the duration, for the interval 1 second. Within the set interval callback function, we call the set function passing in the current date. This will update the time store every second, with the current time of course. If we have a set interval, we need to clear it. We do that by returning a function from the callback function. So after set interval, return a function which is going to clear interval, and we pass in interval. Alright, now that we have the readable store, let's display the time value in a component exported from stores.js, and then in the components folder, I'm going to create a new file called timer.svelte. Within the file, add a script section and import the time store for time from store/stores.js. This time value itself though needs to be formatted for us to understand the interval updates. For that, I'm going to copy paste a function which formats the date time value, and I have called it date formatter. Now in the markup, we can render an h2 tag. It says the time is date formatter dot format, and we pass in $time. Let's include this component in app.svelte and head to the browser. You can see that time is rendered and update every second. We can use this time store value in any component, but the component itself cannot update the time since it is readable store value. Alright, we have one final detail to look at, which we will do so in the next video. The last part I would like to discuss about stores is creating a custom store. Over the past few videos, we learned that a writable store object contains 3 methods: subscribe, update, and set now. As long as the subscribe method is implemented, an object becomes a store. Beyond that, you can add any logic you want to, which makes it really easy and straightforward to create our own custom store. In this video, let's see how to create a custom count store in stores.js. Let's begin by defining a new function. So function create count, and within the function, let's call the writable function. To create a store, let's pass in 0 as the initial value. We know that writable returns an object with 3 methods. Let's destructure them. So const subscribe set and update is equal to writable, but we won't be returning these properties. Instead, we will return a new object. This object will return the subscribe method, as it is so the object is already a valid store. But now we can extend this object with our own functionality. We can add an increment property, which is a method. It will accept an argument size with a default value of 1, and it will call the update function, updating the store value by step size. Similarly, we can add a decrement property which decrements the store value by the step size. So decrement size is equal to 1 and n is equal to n minus size. Finally, we can also add a reset property which calls the set method passing in 0. Now we can call this create current function, assign it to a constant called custom count, and then export it for use in another components in display.svelte. We can import custom count, which is our custom store, in the markup. We can render its value using the $ prefix. The custom count is $custom count. We can also add a button to increment, decrement, and reset the count values. So button, the text is going to be increment, and on click of this button we are going to call custom count.increment. I am going to make a copy of this, change the text to increment 5 and pass in 5 as the step size. Similarly, I can make the copy of this, paste it and change increment to decrement, and for our last button we can add the reset count functionality button. Text is going to be reset, and on click custom count.reset. If you now save the file and take a look at the browser, you can see that we have the custom count as 0, and the various button, the first 5 button corresponds to the button that we have just added. If I click on increment, a count value increments. So increment by 5, decrement by 5, and of course reset. Our custom count store is working as expected. So what we have done with our custom store is expose new methods like increment, decrement, and reset, but hide the update and set methods. This way you can pretty much have any functionality with your custom store. So when dealing with global state management in Svelte, remember about stores, as they let you deal with all the complexities in a really simple way. Alright, with that we come to the end of all the major concepts I wanted to cover in this Svelte series. We have covered creating a Svelte project from the template repo, how to bind text HTML and attributes, how to conditionally render elements, how to render a list elements, and the importance of specifying a unique key. We have also learned about event handling, form handling, reactive declarations, and statements. We then proceeded with the component architecture, props component API, custom events, slots lifecycle hooks, making HTTP requests, dynamic components, the module context, and finally stores. I hope you now have a pretty good understanding about Svelte. Apart from what we have covered, there are a few more features that I haven't covered but Svelte does support. There are topics related to motion animations and transitions. These topics are very specific to an application, and it's definitely a nice to have rather than a necessity, which is why I would like you guys to explore it based on your project requirements. Also, do let me know in the comment section if you would be interested in a series on SvelteKit, which is the logical next step after learning Svelte. But this is pretty much what I wanted to cover in this Svelte series. If you have enjoyed the series, please do consider subscribing to the channel and sharing the playlist with your friends and colleagues. Thank you guys for watching, and until next time, take care. What's going on, guys? My name is Rahul and welcome to the very first tutorial of Svelte framework. Well, I know most of you guys are here